Yet again, another gigantic number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 44 is a 79-digit number. We want to find the remainder when we divide it by 45. So, well, first we have 45 is 5 times 9, so we're going to look at the remainders when it's divided by 5 and divided by 9 separately. So I'll just keep track of that here. Equals something mod 5, and then it's equal to something mod 9. And so for the mod 5 part, that one is easy because every number that is congruent to 0 mod 5 has to end in a 0 or a 5. So every number that is divisible by 5 ends in a 0 or ends in a 5, and this one ends in a 4. And so it has to be congruent to 4 mod 5. Next, mod 9. And for mod 9, we're just going to use the 9 divisibility trick where we just sum up all the digits and find the remainder of the digits of the sum of the digits divided by 9. So put that into action. Let's go 1, 2, and then we have so on and so forth until 9. And then 10, 11, 12, and then all the way up until 19. Then 20, 21, and then all the way up until 29. Then 30, 31, all the way up until 39. And then we just have 40, 41, 42, 43, 44. Now this one is just n into n plus 1 over 2. 9 times 10 divided by 2 is 45. This one is 45, which takes care of all the ones digits, but we also have to take care of the tens digits to sum up all the digits. So this gives us a 1, this gives us a 1, so this gives us a 1. There's 10 of these numbers, each with a 1 in the tens digit, so that's just 10 of the numbers times a 1 in the tens digit. And same thing here, 45 takes care of all the ones digits, plus there's 10 of these numbers for times a 2 in the tens digit. And again, 45, 10 of the numbers, 3 in the tens digit, and this one we can just sum manually. So this is a 4, and then that's still going to be 4. 4 plus 4 is 8, plus 1, 9. 9 plus 4 is 13. 13 plus 2, 15. 15 plus 4, 19. Plus 3 is 22. 22 plus 8 is 30, so this one is 30. Now summing this all up, this is 10, 20, 30. That gives us 60. This is 4 times 45, which is equal to 2 times 90. So that gives us 180. So it's 180 plus 60 plus 30, which is 270. That's the sum of all the digits. Now let's take the sum of the digits, divide by 9. We're going to find that is congruent to 0 mod 9. And I should probably not write the division there, but 270 is congruent to 0 mod 9 because 9 perfectly divides 270. So it's congruent to 0 mod 9 and 4 mod 5. And now we want to find a number that's going to satisfy 0 mod 5 or 0 mod 9 and 4 mod 5. And immediately we can just take out some numbers where 1 is not going to be congruent to 0 mod 9. Clearly that's not the answer. 4 is not congruent to 0 mod 9. That can't be the answer. 18 is. 44 is not congruent to 0 mod 9. That can't be the answer. Now we have 4 mod 5. And so, well, 18 is not congruent to 4 mod 5 because that would be 15. So the remainder is 3. 18 is congruent to 3 mod 5, not 4. And 9 is indeed has to be the answer because we can check that. 9 is congruent to 0 mod 5 and 9 is also congruent to 4, or 0 mod 9 and 9 is also congruent to 4 mod 5. So this satisfies both of these, and so that's the remainder when n is divided by 45.